Good morning to all present. This will be my demonstration for task 1.3 HD. I'm going to tell about the Cisco Packet Tracer. It will be a comprehensive guide for beginners and novices. Going forward, for the introduction, thorough introduction for novices is provided in this lecture. You will discover the fundamentals of networking as well as how to design, configure and simulate network topologies. If you have to learn anything, you need to know its motivation and what it is. Hence, let's see what is Cisco Packet Tracer. It is a network simulation tool which enables you to design and configure network topologies as well as simulate network devices. Students, educators, and professionals utilize it to learn and put networking principles and techniques into practice. You may configure, design, and debug network using Packet Tracer in a secure virtual setting. For you to understand this, you need to familiarize yourself with networking fundamentals. These include IP addressing, subnetting, routing, and the OSI model. To aid you in using Packet Tracer, we will briefly go through these ideas. You can design more intricate network topologies if you understand how networks operate. Coming to creating the network topologies. You can design network topologies in Cisco Packet Tracer by dragging and dropping network devices into the workspace and then connecting them with wires. Specific configurations options for each device are available, including IP addresses, subnet masks, and default gateways. Additionally, you can simulate other network circumstances, including traffic congestion and network breakdowns. Simulating network devices. You can simulate network devices like routers, switches, computers, and server using Cisco Packet Tracer. These devices can be set up to carry out particular functions including packet routing, frame forwarding, and application executing. Additionally, you may fix network problems and keep an eye on network traffic. As a result, you can practice actual networking situations in a secure virtual setting. This lecture will be focused on the practical part of Cisco Packet Tracer. Hence, let's begin with it. First, I will be talking about how to make a basic local area network. First, we'll go to the switch part over here on the bottom left. Then we can connect to a switch over here. We can have multiple switches. In networking, switches serve as essential components that enable the connection and communication between devices on a local area network. The primary purpose of switches is to receive, process, and forward data packets within a network. Now, coming to the end devices, we will be using PCs to show the demonstration, a communication between. Now, coming to the wiring part, we can actually go to this connections part and select this lightning bolt. This will automatically assign the required wire to both of these ports. We do not require to configure anything in switches as such, but over here we can configure all the PCs to start communicating between each other. You can either go for static or DHCP configurations. DHCP automatically assigns the IP address as well as the subnet mask, but we will be learning the static configurations of this. Before this, one thing I have to tell you is that we need to add nodes to the corresponding PCs to keep a track of their IP addresses. Once we have written the corresponding IP addresses, we can try to configure it. First, we go to desktop, we go to IP configuration over here. Now we type in the address that we have written over here. So once I press tab, the subnet mask will be automatically assigned. The default gateway is not required right now. It will be required when we use routing in the system. PC0 has been configured. Coming to the PC2, now PC1. Now all of the PCs have been configured and it should be able to share data from one PC to another. To check this, we can either go in real time or the simulation mode. First, we will go with the real time. We have a simple PDU. We'll be sharing it between two PCs, PC0 and PC1. As you can see, it shows successful on the bottom right side of the screen, which means the message has been successfully passed on. Testing for PC0 and PC2, it should show successful as well. Similarly, you can keep on testing, sending messages from PC2 to PC0, PC2 to PC1, and so on. So congratulations guys, you have learned how to make a basic LAN. Going forward, we will be discovering how to connect it to the router and have a static routing. Now coming to the next part of the tutorial, we will be actually making two LANs. Typing in the details of LAN, which is 192 for HP. So we have to drag a router over here, which is a 2901. It is a device that connects multiple networks together, such as connecting a local area network to the internet of connecting different LANs. So routers operate at the network level, which is the layer 3 of the OSI model, and performs several key functions like packet forwarding, inter-network communication, and network addressing and translation, as well as traffic management and QoS. Going forward, we also have to make another LAN, so we will be using this over here. So once we have done that, we will have another switch over here to manage this LAN. It can be connected to multiple PCs, so we will be having some end devices over here. Selecting these end devices, and we have to configure them before, so we will be testing this LAN first and connecting this to the router later on. So as we have connected over here, you can see the link is being processed. It will take some time, but it will eventually be connected to switch. So coming to the configuration part, first rather than configuring, we should note down their IP addresses. That's what I'll be doing. Default gateway will be set up right now. We will be changing it, and for now it is left empty. Going to PC4, we will be setting up the IP address of it and the subnet mask. Similarly for PC5. Sorry, I forgot to change the IP address. It is 1.3 over here. So yeah, once done this, we can either check it by pinging to the corresponding IP addresses, or we can just directly send the PDU. Since I've told you how to send a simple PDU, I will be showing you how to ping from one device to another to check the communication between them. First we go to terminal. Sorry, my bad. First we go to the command prompt and basically type in the ping command, which is I want to ping to this PC4, hence its IP address is 192.168.1.2, which I will be typing over here. As you can see, the connection has been successful and they can communicate. But if I switch the IP address to another LAN, which is your 192.168.0.1, which is a part of the left hand side LAN, it should not work. As you can see, I do not get any reply. So the testing has been done. I think it is clear. Now, just to make sure that this is working or not, I'll be first deleting this real-time experiments over here and adding more of these. From PC3 to PC4 it is successful. Similarly, from PC4 to PC5 it is successful, and from PC5 to PC3 also successful, which means we have set up this LAN successfully. Coming to the router part, but we will have two interfaces, which is the gigabit Ethernet 0/0 and gigabit Ethernet 0/1. What we have to do is simply connect the switches to the routers, one of the router. Once we do that, you'll see this red triangle, which means that the port is not active right now. To set up the port, what we have to do is give another IPv4 configuration. The IPv4 address will be similar to one of these. So I will be typing in the IP address for it, which will be this. Once we set this up, you can see the CLI changes a little bit. This will set up the IP configuration of gigabit Ethernet 0/0. Once I have done that, I have to press the port status to on. You can see it's trying to make the connection. Once it's successful, it should show two green triangles. So similarly, we have to type in the IP address set on this port. Hence, we take a note of it. And going forward, we also add the IP address for this as well on the gigabit Ethernet cable 0/1. So once we do this, we have to label it properly so there's no confusion between. So we go to 0/1 and assign the IP addresses, which is this. Now what we have to do is, it's really simple. You can see the connection has been made with a switch, and now PC0 can be communicable with PC3, but not yet. What we have to do is to configure every IP address again and change the default gateway to the router's Ethernet 0/0, which is 192.168.0.4. Once I've done that, this PC will be able to connect to router. To test this, what we can do is, wait a second, I have to delete this so you don't get confused. On the bottom right, you can see the section for real time. So it says successful, which means this router has been connected to PC0 properly. Similarly, for all the other PCs, it's going to be PC1 over here, IP configuration. We're setting it to 0.4. Just to make sure I'm not making any mistakes, what I'll be doing is trying to hover over this part. You can see it shows gigabit 0/0 and it shows FA 0/4, which confirms the ports which our wires are attached to. Similarly, we have to configure all the other PCs. The gateway for this will be different as it is a part of another LAN, but all the gateway for all the LANs, but the gateway for PC3, PC4 and PC5 will remain same as they're part of single LAN. It can change accordingly, but for now we are keeping it same. So now what we have to test is that is PC0 able to communicate with PC3. I'll be showing you with the ping command. So I have to ping to 192.168.1.1. First I might get a timeout, but consequently it will be able to communicate. You can see first I got a timeout, but further on, once the connection is established successfully, it will keep on communicating. Now if I do this or perform this command again, you'll see it starts replying from the start. Similarly, if you try to share a PDU from one part to another part of the LAN, it might show unsuccessful at first, which is failed over here, but once you try it again, it will show you successful. Congratulations guys, you have learned how to connect one LAN to another LAN. Also, you can go for the simulation mode over here. What does simulation mode do is, First I have to reset this and delete all this over here. uh, we will be starting fresh for the with the event list. We'll be sending this to this, and from PC1 to PC3 you can see it has ICMP. Basically, the Internet Controlled Message Protocol is a network protocol that operates at the internet layer, layer 3 of the TCP/IP protocol suite. It is used by network devices such as routers and hosts to send error messages and control information regarding the transmission of IP packets. As you can see, this we have set up the simulation, and once we start it, it will show you how the PDU message goes through the process of sharing. We can speed up the process by this slider over here. This can clear your concepts about how the communication process happens. And now you can see the communication has been completed and both of the status is successful from PC0 to PC2 and PC0 to PC3. One thing you might have noticed is the ARP packet between the communication. We did not send it by ourselves, but it generates automatically. One would ask, what does ARP do? So, ARP stands for Address Resolution Protocol. It is a protocol used in computer networks to map an IP address to a physical MAC address. The primary purpose of ARP is to facilitate communication between devices on the same local area network. Now we have successfully made and connected two LANs using a router. Now we will be using two routers to connect three different LANs. You have to go to the network devices and select the router again over here. To do so, I would recommend to use 2621XM or 2620XM. I will be using 2621XM. I have to configure this router again, which is I will be deleting this router. Yes, and I will be deleting the messages that I have sent over here. Okay, so we're going this. We will be putting this over here. This will be deleted. For the configuration part, we need to configure the Ethernet cables over here. It's the serial ports over here. You can directly connect this over. Just a second. For this, what we have to do is to add a VIC2T for serial communication purposes. Right now, the router was on, so I'm going to switch it off and add this following modules to it. Once you have added the modules, you can switch on the router. So now I'll be making the connections and configuring the network. So it does take some time to boot up, so we will be waiting for this as it's a simulation and trying to simulate the real time. I will be connecting the wires till then. Now coming to the configuration part, similarly we will be having the configuration to the LANs. This will go over here, and in the configuration part we'll be pasting this and changing it accordingly. So for the fast Ethernet 0/0, you can hover over this cable to check where it is connected. As you can see, it's connected to FA 0/0, which is fast Ethernet cable 0/0. Once you do that, switch on the port status. Do not forget to do it because it won't be able to communicate between. Going forward, we will be connecting the second LAN. Once I do this, I have to switch on the port and it should communicate between these two as well. Now to set up another LAN on this router, we need to do the similar things that we have done for this router 3. First I have to define the IP address or the gateway I'm going to use. First I have to define the LAN IP address. Going forward, we will be using a switch over here, connecting this to the PCs. For testing purposes, I'm just gonna use one PC because I don't want to make the network too complex for you guys to understand. 3.1. Maybe skipping over here, typing this over here, and should be 3.2. And we have to set up the serial communication over here. As you can see, we will be covering this once we set up this LAN 3. This will be referred to as LAN 1, this will be LAN 2, and this will be LAN 3 throughout the video. So I will be wiring them up. And we have to configure this router as well. So to confirm which Ethernet cable is being connected, we can hover again and check it's fast Ethernet 0/0. Hence we have to go to this and type in the corresponding IP address. Once done that, oops, I forgot to switch on the port. There you go. So it will start communicating. Now we have set 3 LANs and have 2 separate routers. Now we will be showing you the serial communication between both of them. To make it more interesting, we can actually add another LAN, which I'll be doing right now. Let's go over here and add another router, which is 2621XM, which will be our router 4. Now I'm going to switch off this router first and add the, either you can add VIC 1T or you can add VIC 2T. VIC 2T, the difference between them is just that it has 2 ports in VIC 2T, and in VIC 1T it has only 1 port. I'll switch this on and make the connections accordingly. First I have to create a switch over here, so I have to configure the LAN which I'm going to be using over here. We'll just press N over here and type in the IP address that we are going to use for this LAN. So once that's done, I will be adding another PC for demonstration purposes. Though I haven't configured this PC as well, I guess I will be configuring this PC. The gateway for it will be 4.2. Guys, this is totally random. You can change it to 4.3, 4.4, 4.5. So I'm going to make the connections now. And wait a second, let me check if I have configured PC6 or not. Yep, I haven't configured PC6, so I will be configuring this first so I don't get any issues while communicating between devices. So we have set up the PC6 over here, and let me see for the router 2 if we have configured it or not. We have configured the router 2. We do have to communicate between router 3 and router 2. To set this communication, I will be showing you how to configure the serial ports over here. You can see it is connected to serial 0/2. To configure this, I have to configure this part of the serial port. Similarly, on this router 3, it is connected to serial 02 as well. Going forward, setting up the LAN 4, which I'm going to call it. First we'll, okay, so this router has been switched on, and we will be configuring the network over here. And I again forgot to switch on the port, so I'll be switching it on. So as you can see, it's trying to make the connection, and once it's established, it will show two green triangles. Not to get confused between LAN 3 and LAN 4, I'll be dragging this over here to show you that this is LAN 3 and this is LAN 4 at the corner. Now we can connect these two as well with the Thunderbolt connection. This is connected to serial 3 and serial 2 on router 4. Now configuring this part, what we can do is we can assign the IP addresses that we want to communicate with. We'll be using 5.2, and we can type in over here 5.3. Come to this port, we can type in 6.2 and 6.3 over here. We are not using DHCP, so we need to use the static IP routing, which comes in this section. I will be explaining this further in this video. Now setting up the serial ports, first we have to change the serial over here to the IP address mentioned or labeled in the diagram. The subnet mask will be automatically assigned for all the IP addresses, so you just have to press tab button. One thing I forgot to do before was to switch on this port on serial 2. Never forget to do so because it won't communicate until and unless you have switched on the port. Just to confirm if I've labeled it correct. Yep. So you can see the communication has been started. To check if they are communicating or not, you can just send a UDP packet from PDU packet from one place to another. You can see it is successful. Hence, you can confirm that the serial communication is taking place. But one error you will be facing right now is if you want to send a message from PC2 to PC6. As you can say, as you can see, it says failed. For this, you need to use static or dynamic routing. Dynamic routing is quite easy and simple to use, and normally that's what people prefer, as it takes out the human element for routing purposes. But for the tutorial purposes, I will be showing you static routing as well as dynamic routing. Similarly, I'm going to be configuring this serial 3 over here with 6.2 and serial 2 over here with 6.3. Now they can communicate between each other. I will be communicating between two routers to check if it's possible. First it has said failed. Let's try it again. Now it says successful. As you can see, it does take time to set up as we are doing a simulation and it is in real time. Now to configure this PC7, I will be entering the corresponding IP address to it, and the gateway will be as labeled. This has been set up. I do need to set up this fast Ethernet. Okay, so this has been set up as well. Now coming to the static routing part, this will allow us to communicate between all of these LANs through the routers. So now we will be performing the static routing, which is we are going to define the routes by ourselves to make it possible to communicate between devices. Starting first with the router 3, we will go to this routing section over here, and we will enter the network we need to go to or communicate with. In our case, it will be first 192.168.3.0, and it will be 192.168.6.0, as well as 192.168.4.0. There will be three routes that we have to set up. Let's start setting it up. First one will be 3.0. Mask, you can actually copy paste the mask again and again. The network that we're trying to communicate is 192.168.3.0. The subnet mask will be 255.255.255.0. One might wonder how I have allocated this random mask to it. To get this concept clear is, what you can do is, you can see the classes of the subnetting mask. This network IP belongs to class C, whose subnet mask is assigned as this. Going forward, I have to show the next hop. So what will next hop be is, whichever serial port it is connected to, which is the next network it is going to communicate through. So I will be typing in this as 5.3. Once I have typed in these details, I have set one of the routes. Going forward, I will be setting other routes as well. Now we will be communicating to 6.0. The subnet mask will remain same. As you can see, this IP address starting from 192 belongs to class C. The next hop will also remain same throughout. Similarly, I will be typing in the 4.0, which is our LAN 4, and we will be assigning. So all of the information has been completed. We will be following the same steps for router 2 as well as router 4. If you want to practice it on with yourself, you can stop the video and configure it and verify once you have done it. We go to the configuration static and enter the network. For now it will be 0.0. The subnet mask will be similar, which is 255.255.255.0. And the next hop over here, there will be two next hops, by the way. First one will be 192.168.5.2 and the other one will be 192.168.6.3. To communicate between 192.168.0.0, which is the LAN 1 and LAN 2, I have to type in the next hop as 5.2. So I will be changing it to 5.2. Similarly, if I want to add a route for LAN 2 as well, I need to type in the network as 192.168.1.0. So basically we can add this static route, and you can see it has been added over here. So to communicate with the LAN 2, I have to add this static route. Once it has been done, I have to change the route to LAN 4, which is 4.0. Also I have to change the next hop because now the next hop is equivalent to 6.3. Once I've done this, you can verify the details and just keep on adding it. You can see it has three static routes, but if we had only one LAN on router 3, it would have had only two static routes. Coming to the router 3, just to confirm that I've given the right static addresses or the static routes. So now we will be setting up the router 4 static routes. So the next hop will always remain same, which is it will remain 6.2, 192.168.6.2, and the network we want to access first is, let's say, LAN 3. So we will be typing in the corresponding IP address. Mask will also remain same as it belongs to class C. The next hop will be 6.2, as I explained. Once this has been added, we can go further on and add the address for 5.0 going via 6.2. Similarly for 0.0, let me just confirm it. Yes, it is 0.0. and also for 1.0. So you can see we have added 4 routes going through 6.2. So I was facing some errors to communicate between LAN 1 and router 3. So I have just done some debugging and testing. What I discovered was, for some reason, either it's bugged in CPT, that the 192.168.0.4 port or the IP address configuration did not work for this. So once I changed it, you can see I'm getting the successful signals over here, which is from PC1 to router 3 and PC0 to router 3, as well as PC2 to router 3. So we will be making the LAN 2 again. As you can see, I've changed the IP address for fast Ethernet 0/0. Now I'll be changing the IP address for this, which is, I'll be making it to 1.5. Yep, I have to label it as well. So we will be adding this IP address to one. These PCs are communicating with router 3. So to do that, I can actually switch off and on the port again. The connection has been made over here, which is, if I see two triangles, it means that I can start testing. I will be deleting these messages to make it clear. So for the testing purposes, I'm going to test LAN 1 connection with router 3, as I was facing some errors first. You can see it's successful now. Yep, all of the PCs are communicating with router 3. Now the link has been made. I will be testing it for PC9 and router 3 communication. Yep, it's successful. So nothing changes. We have already made the routes so they can communicate with each other. The static routes can be seen over here. I haven't made any changes over here in the static routes. Similarly for router 2 as well as router 4. First we will try to communicate between the PC6 and PC7. The first response might be a fail. It is successful, as you can see, the connection between PC6 and PC7. So to make sure this router is working, I will be communicating between PC9 and PC0 first. It is successful, which means this router is working as needed. So now we will be communicating between PC0 to PC6. You can see a successful message has been shown. Next, from PC0 to PC7. Yep. So we have successfully made 3 LANs and connected them with the routers and showed the communication between them. One thing more we can add is, to demonstrate, we can add a home network, which is a wireless home network. I will be adding another router over here to demonstrate that. We will be going over here. Yep, let it boot. First we'll actually switch it off and add VIC-20, because we just need one serial port for communication. Yeah, I forgot to power it on, so I press it over here and power it on, switch it on. We can connect this from router 4 and start configuring this part as well. I will be assigning the IP address over here, which will be 7.2 as well as 7.3 over here. Just to make sure where it is connected, I'll hover over the wire. This is connected to serial 3 port. I'll type in the corresponding IP address. As you can see, I've entered the IP address and switching on the port, it will allow me to communicate. Similarly for this, I'll go to configuration as well as serial 0. Over here I will be typing in the IP address, which is 7.3, and the subnet mask will automatically assign itself. And switching on the port, you can see we can communicate. To make sure that these are communicating, you can send a packet from this router to this router. First it might say failed, as I've told you, but in the second try it should say successful. As you can see, first it says failed from router, let me just increase the source part. Yeah, from router 4 to router 5, but then you can see it says from router 4 to router 5 it's successful. So I'll be deleting all this part and adding the switch over here to make a, not a switch actually. Now we will be doing something different, which is adding a wireless device, which is a home router. you can see, we can communicate between laptops using this, though the PCs in this CPT will require you to have the Ethernet cable connected. We have two laptops, and also we can have another device name like a tablet or a smartphone, either of those. I'll be using tablet for this purpose. It will automatically connect, as you can see, because it's using DHCP. So continuing with the part, I will be showing you how to use the home router. I've used laptop 0 and laptop 1 as well as the tablet PC 0. For default purposes, it will be set to DHCP on its own, but we will be using static. So we will be using static routing and going to configure over here. Once we go to the internet, we will go over here static, and the default gateway will be. We haven't assigned any gateway yet, so we will be doing so right now. Yep, it says invalid IP address because I haven't entered any IP address right now. We will be using, let's use 8.5, and we will be using 8.0/24. Going further, we will be using 8.1, similarly over here 8.2, similarly over here 8.3. The gateway for this will be 8.4. One thing I need to correct is, for some reason, typing so quickly, I forgot to mention this. It should be 8.2 and 8.3 rather than 1.3 and 1.2. So once we have set this up, you can see it has communicated directly first, but the tablet is set on DHCP. Once you go over here in the configuration, you can see the wireless part is set to DHCP, which I have to change to static now. We will be setting up this router. We'll go to static over here. Default gateway will be equivalent to 8.5, and we will be going to LAN to set up this. It is normally set to DHCP. I think right now it's on DHCP. Let me check. Yeah, we have changed it to static, so we can change this accordingly. But if you want to use this 192.168.0.1, you can do so. What we can do is to change it to point 8 point, let me check the label diagram, 8.4. So it will give you some errors like this, but just ignore them and keep on entering the gateway over here. Wait a second. Once you enter the gateway 8.5, you can go to LAN over here and just close this. Now our router has been set up. We have to connect it with the main router, which is router 5. We have to set the Ethernet cable over here, setting up the 8.5 as my IP address, as well as mask will be set automatically, and switching on the port. You can see the connection has been made, and they are connected. This will show you a wireless LAN as an example. Just differentiate it from already existing systems. Okay. So this will be our LAN 5, by the way. So we'll go to laptop 1 now. We have to configure it. So the issue in this is that these laptops aren't wireless by default. So first we have to switch this laptop off, and this is the module we have to take out. Just a second. Once we take out this module, we have to add this, which will allow us the communication, which is a Linksys WPC 300N. It is an antenna to communicate between the router, the wireless router. Okay, so I forgot to switch on the device. I will switch on this device. Go to desktop and IP configuration. Once I go to the IP configuration, we have to change it to static. Once I change it to static, it should disconnect this part. We'll be adding the IP address on my own. The IP address will be 8.4 over here, and not the 8.4, actually 8.1 over here. The gateway will be 8.4 according to the label diagram over here. Once I set this, I can just switch it off, and to check the communication, let it boot or let it connect properly. So we will be sending a packet from this to this. You can see it is successful, so hence it is communicating with each other. So there will be no actual difference. We'll do the same thing with laptop 1 as well. We'll just take this out. Okay, so I forgot to switch on the power. Take this out and add this over here. You can see it will actually automatically connect right now. Once I power it on, it will automatically connect to router 0. This is because the laptops are automatically set to DHCP. So when I go to this configuration part, IP configuration, you can see it has been already set the IP address of this device, which is not as the labeled address. It has set the gateway as the labeled because it extracts the data from it. So we are not using DHCP. We will be going to static and assigning the IP addresses by ourselves. So once we have done this, the addresses are same, so it will keep on communicating, and once we try to send a message from here to here, it should be successful. Similarly, tablet is also set up in DHCP. Oh, no, it's set up in static, so we have to change the stuff as well. 8.3 tab, and it is 8.4 over here. Once we have done this, we can just switch this off. We use default gateway. Yeah, it just mentions a warning over here. You can just ignore this part. So now we will be communicating between these devices. Yes, you can see this is a wireless LAN that we have made, LAN 5, and they can communicate between devices as well as the home router. So congratulations to all of you. You have learned the basics of CPT, and you can keep on adding more features and use this as the fundamental to make any activity or make any projects you are wondering, or just basically use it as a simulation tool to explore more about networking and communication. For the testing purposes, I will be using the simulation mode right now to show you how it is communicated between each of them. So I have to zoom it out. It's a bit zoomed in. So we will first go from LAN 3 to LAN 4, or communicate between LAN 3 to LAN 4. We'll just increase the simulation speed. You can see that it will send an ICMP, which I explained in the starting of the video. You can see the message goes from these places, which is from PC6 to switch 2, switch 2 to router 2, router 2 to router 4 to router 3, switch 3, switch 3 to PC7. And once it confirms that the connection does not stop over there, it sends the DTP packet as well as the STP packet, and it keeps on going. As you can see, it has shown the successful status between PC6 and PC7. Um, One thing I forgot to mention was the dynamic routing and how it works. It's quite simple. Once to test that, we can just remove all of these. Going to the RIP, which is a dynamic routing strategy, we have to type in all the IP addresses that we have to access, and we do not need to type in the next hop and worry about anything else. So now I have successfully removed all the static routes that I had defined. So we have set up all the RIP, which is the dynamic routing. I have to show you how to add it. So once we open this, this is the router 3. The configuration is as follows. First we'll add the LAN 1, then LAN 2, which is 1.0, further going on LAN 4, LAN 5, as well as the routes, which is the 5.0 connecting to router 2, and 6.0 connecting to router 4. You have to do similar things for both router 2 as well as router 4. You can either do it by yourself or just verify or enter right now the details of the RIP. To verify, let me check. I have added 0.0, 1.0, yes, 3.0 is, is this, 4.0, 5.0, and 6.0. This has been verified. Also for this, I need to verify I've entered 4.0, yes, 3.0, 1.0, 0.0, 5.0, and 6.0. So it should be able to communicate between each other. So as you can see, it's successful from PC8 to PC7. It is successful. So all the routers are communicating with each other. You can also check for PC1 to PC6. It is successful. I hope you liked my demonstration. Thank you and have a nice day.